For years, one country has dominated the electric vehicle revolution, not just by making EVs, but by controlling one of their most critical components, the permanent magnet. Around 90% of the world's rare earth supply and nearly 94% of permanent magnet production used in high-performance EV motors is controlled by China. These magnets, made from rare earth elements like neodymium, are essential for most modern electric vehicles. In the past, China has even restricted exports during geopolitical tensions, putting pressure on global automakers. But now, India may have found a way around this dependency. A Bengaluru-based startup called Vimag Labs has developed and patented a revolutionary electric motor that works without rare earth permanent magnets. Instead of relying on expensive rare earth materials, the company has created what it calls the Virtual Magnet Synchronous Motor, or VMSM. So what makes it different? Rather than using permanent magnets, Vimag's motor generates the required magnetic field in real time through a combination of advanced software, power electronics, and intelligent control algorithms. The company says this approach delivers performance comparable to conventional permanent magnet motors while maintaining a brushless, slip-ring-free design. Instead of rare earth magnets, the rotor uses ordinary copper coils and steel. Sophisticated software then controls the electromagnetic field wirelessly inside the motor, performing the same role that permanent magnets normally would. This is why experts say the real innovation isn't simply removing magnets. It's replacing their function with software. According to industry expert Gaurav Vangal, Associate Director for Light Vehicle Production Forecasting at Mobility Global, magnet-free motors already exist and are used on roads today. However, Vimag's breakthrough lies in achieving the same power and energy efficiency as permanent magnet motors through software-controlled electromagnetic technology. If successful, this could significantly reduce the global EV industry's dependence on China's rare earth supply chain. The timing couldn't be more important. According to Benchmark Mineral Intelligence, more than 86% of EV motors worldwide currently use permanent magnets. These motors are popular because they are compact, highly efficient, and require no external power source to maintain their magnetic field. However, they also depend heavily on rare earth materials, whose prices can fluctuate dramatically and whose supply remains concentrated in a handful of countries. Vimag Labs believes its technology can solve both problems. Speaking to NDTV, the company's founder and CEO Manish Seth said their software-driven motor aims to match or even outperform traditional permanent magnet motors without sacrificing driving range, acceleration, or energy efficiency. According to the company, both internal testing and customer trials have shown performance that exceeds conventional designs. Because the motor eliminates expensive rare earth magnets, it could also become significantly more affordable and less vulnerable to global supply disruptions. The startup has already completed its research and development phase and is now moving toward commercial production. Its goal is to manufacture between 1,000 and 10,000 pilot units by the end of this year, with full-scale mass production beginning next year. Initially, the technology will power electric two-wheelers and three-wheelers, before expanding into electric cars, bushes, and trucks. Vimag Labs has already secured its core patent, filed multiple additional patent applications, and raised $5 million in funding to accelerate commercialization. If the technology delivers on its promises, it could mark one of India's biggest breakthroughs in electric mobility, reducing reliance on Chinese rare earth supplies, lowering manufacturing costs, and helping build a more resilient global EV supply chain. The question now is no longer whether electric vehicles are the future. The question is, who will control the technology that powers them?